And they're all going to be a couple hours apiece. Right, I'm assuming it's going to be around, take 5 hours. So
So to answer your question,
it'll depend. Because I'm just wondering, you can get a pretty decent, not even good, decent 3D printer for $400. You gotta tinker with it a little, but it might be nice to just go to class and go, I'm gonna print this and be done with your bag. No, that's kind of what I thought. I got a lot of coding I can do. We're doing a mini rescue bot. It's gonna be about yay big. It's gonna have a lot of interchangeable parts that just like slide on. So you don't send down. It's also supposed to be inexpensive. So like, let's say you're trying to crawl through some rubble or something. You don't need 30 sensors on it. You just put on what you need and then build out. So if it does get flushed, you'll lose it. But for the first, what I want to get done is, eventually I want it to kind of have interchangeable drivetrains. So like tracks, like wheels, maybe legs if you get crazy. But at the bare minimum, I want it to move, and I want it to have at least like 2 or 3 interchangeable parts. Like you're gonna toss around a drill to like take a sample of something, a robotic arm, and a huge battery for like long. So that's kind of what we're doing.
Alright. Good afternoon. Since the projector is not working, so I'm gonna use only the boards today. So, any questions? Before we start.
For number 2 on the homework, it was a little ambiguous on the assignment sheet. It was asking us to do MATLAB for the analytical approach. Were we actually supposed to draw that graph?
No, forget about the second part.
Okay, good.
No need for
Because
drawing.
it was a little confusing because it said like,
did draw it graphically? Is that an issue?
No,
minus 10 points.
No,
You get a
since
5.
I copied and pasted from the first problem, I forgot to remove
Okay,
the
cool.
graphical part.
Cool.
But if you draw the mechanism, it's gonna make sense. All right. Not successful. So we were talking about displacement analysis for 5-bar mechanism. With A, B, C, D, and E, we label the angles, the lengths in this pattern theta, beta, phi, and eta. So the vectors can form the vectors in this way. We did everything on yesterday class. If this is OA, A, B, C, and OB, OAA plus AB this point has two vectors ending to that, so I reach to this point, I stop, put the equality sign, and try to move to reach to that point through the other path. So OA, OB, OB, C plus CB. So OA, OB plus OBC plus CB. Then we derive the x component equation and y component. X was a cosine of theta plus b cosine of beta equals to e plus d cosine of eta plus e cosine of phi. Just change cosine to sine. E doesn't have any y components, so it's going to be 0. E cosine of theta plus d sine of phi. Constants, there's A, B, C, E, and E. Variables are the angles. Nouns are constants plus 2 degree of freedom, 2 out of 4 should be given. So we assume in this case theta and eta are given, we are solving for the other two. So two equations, two unknown. If you want to solve for theta and phi, we kept this in one side. We move a cosine to other side. We squared and add them up. We could get rid of beta, and we are going to solve for phi. We define some intermediate variables to make the equation. Just simplify the equation. So m was d cosine of phi theta plus e minus a cosine of theta. M and n is going to help us to simplify the notation. We did it on yesterday's class. D sine of theta minus a sine of theta. These two would be nouns because theta, a, e, theta, and d are noun, so m and n would be noun term. And we define p and q and r, 2mc, and ms squared plus ms squared plus c squared minus b squared. And we could end up to p cosine of phi plus q sine of phi plus r equals to 0. This was the last equation that we derived on Wednesday class. So the only variable, the only unknown is phi, but it's a nonlinear equation. If you want to solve this nonlinear equation, like as four-bar mechanism that we did, we are going to use tangent half angle. So we assume that t is going to be equals to tangent of half angle of phi over 2. So cosine of phi is going to be 1 minus t squared, 1 plus t squared. Sine of phi is going to be 2t dividing by 1 plus t squared. If you substitute cosine of phi with this one and sine of phi with this one, you will get a quadratic equation I'm just rewriting. Multiple both sides by 1 plus t squared. We can get rid of this 1 plus t squared. This is getting 1 plus t squared. So I'm getting p 1 minus t squared plus q times 2t plus r 1 plus t squared equals to 0. If you simplify this and collect t squared and t terms on the constant part coefficients, you will get a equation like this: r minus p t squared plus 2q times t plus r plus p equals to 0. R, P, Q would be noun because we define them here. R, P, Q are the parameters as a function of m and n, and m and n would be nouns. So you can find t. Find t tangent inverse of t is gonna be phi over 2 . So phi would be 2 times tangent inverse of t. We could find phi. If you find beta, we are done with the displacement analysis. We look at this equation and this equation. Cosine of beta equals to m minus plus e cosine of phi dividing by b, because e plus d cosine of eta minus a cosine of theta is m. I'm just writing m plus e cosine of phi dividing by b. It's going to be cosine of beta. And sine of beta is, if you move this to the other side, you will get n plus e sine of phi dividing by b. You calculated phi from here, you plug in phi there, you will find two angles. Phi beta 1 and negative beta 1, beta 2, 180 minus beta 2. So find the matching pair between them, and you are gonna have the first node. For the second phi, do this one again and get the second node, and we are done with displacement analysis. I'm gonna work on an example, but for the homework 5, one of the problems is asking you to write a code to do the 5-bar mechanism analysis by that code. Any question? So we are given with a 5-bar mechanism with a length of 1 inch, 3 inch, C is 4 inch, D is 1 inch, at the input angle of, and E is 3.5. At the input angle of theta equals to 45 degree and eta equals to 60, we are going to do the displacement analysis. If you are given with only one angle, you cannot solve the problem. You cannot do the analysis because the degree of freedom is 2. You need to provide 2 angles. And here I assume theta and eta are given. I solve for the other 2, but you might be given with the different combination. But this is valid only for picking theta and eta as the input. If you pick the other combination, you have to derive the equations again. But in the homeworks problem, we are gonna stick with this, theta and eta. So let me get rid of this part. So first thing that you need to do, you need to find the value of M, N, P, and Q. I will start with M. M would be D is 1, cosine of eta, which is 60, just plus E, which is 3.5, minus A, minus 1, cosine of 45. Just use your calculator, find that, 3.293. N is D sine of 60 minus A sine of 45. It's 0.1589. P is 2mc, is gonna be 2 times 3.293 times C. C is 4, 26. And Q is gonna be 2mc, is gonna be 1.27. The last step is R. (3.29) m squared plus n squared 0.1589 plus c squared, which is 4, minus b squared, which is 3 power 2. It's gonna give me 17.8969. Now you have P, Q, and R. You can form this quadratic equation. This quadratic equation is gonna look like if this is, let me write it down. R minus P is negative 8.475. R 2Q is 2.54, and R plus P is 44.21. So it's going to be negative 8.475 T squared plus 2.54 plus times T plus 44.21 equals to 0. So you can use either roots on the MATLAB or solve for the roots of this quadratic equation. You will find T1 equals to negative 2.139 and T2 equals to 2.439. I will start with the first mode, which is negative 2.13. P is gonna be 2 tangent inverse of 2.139 is gonna be negative 129.88, or if you don't like negative number, just at 362 this, you will get 230.11. And for t equals to 2.439, phi is going to be 2 tangent inverse of 2. I forgot negative. 2.4399 is going to be 135.41 dB. So mode 1, mode 2. So now I need to find beta corresponding to first node and beta corresponding to the second node. Any questions so far? So for the first node, what you need to do, you just need to plug in phi, m, and b on the first equation. Cosine of beta equals to c, is it e or c? It should be C if I wrote E. It should be C because C is the length of the angle is phi, so the corresponding length is C, so it should be C. So C cosine of phi is 94, cosine of angle is either negative 129.88, or use the other angle, plus 3.293 dividing by b, which is 3, you will get negative 0.243. So beta is gonna be either 75.96 or negative 75.96. Do the same thing for the sine. Sine of beta is gonna be 4 sine of negative 129.88 plus n. And n is right here, 0.1589. Dividing by b, it's going to be negative 0.97. So beta would be negative 75.96 or 180 minus 75.96, which is 255. So 1, 2, 3, 4. The angle which can satisfy both cosine and sine term is going to be this. So for phi equals to 230.11, beta would be negative 75.96, or if you like to work with the positive number, 284.04. For this we do the same things. I'm just writing the final result. Beta is gonna be 81.49. Node 1, node 2. So this is all we need to calculate for 5-bar mechanism. So on the homeworks problem, you are given with the same 5-bar mechanism, but the input angles are different, and you are supposed to write a code to calculate flow length. Good? Any question before we move on? Go to the slide. So we started from this quadratic equation. So to calculate the coefficient of this quadratic equation, we need to find R, P, and Q. To find R, P, and Q, you need to find M and N first. So M, N, P, Q, and R will be calculated first. Then you can find the roots of this, and by finding the roots, we can solve for phi, and then back to these two equations, solve for beta. Any question? All right. Inverted slider crank. So far we talked about offset slider crank with no offset, 4-bar mechanism, and 5-bar mechanism. This is the last mechanism that we cover before we go to the multi-loop mechanism. So let's see what is the inverted slider crank, then we can start the analysis process. So look at this 4-bar mechanism, which is familiar. To us. So it's a 4-bar mechanism. 4-bar mechanism has 3 moving links, 4 joints. All joints are pinned. 1 pin, 2, 3, and 4 pin. No prismatic or no sliding joints you can see there. Now, inverted slider crank. For inverted slider crank, if I remove this joint and say I don't want to have a pin, I would like to have a prismatic joint between link 3 and link 4. Then it's gonna look like something like this. So here we don't have a pin, we make a slider, but no pin here, just prismatic, and then it's gonna be connected to this link. It has been welded to this, so this part is a part of link 4. So there is no joints between this guy and the slider. So there is no pin right there, here. So if you remember, for a slider crank, we had 1 pin here, which could connect the slider to this link. But here we don't have any pin there. So what do you think about degree of freedom for this? for the new one. Still 1 because number of links, I didn't change number of links. Number of links is 4, 1 ground, 2, 3, and entire of this is 4. I don't have any joints here, so this is not a separate joint. It's part of this link. So 1, 2, 3, and 4. Number of joints, 1, 2, 1 joints between link 3 and 4, but it's a translational, which is fine. Still, it's 1 degree of freedom joints. So number of joints is going to be 4. Same as here. 4 joints, 4 links. So degree of freedom would be 3 times 4 minus 1 minus 2 times 4, 9 minus 8 equals to 1. We call this a slider crank mechanism, and we would like to do displacement analysis for this one. Is that clear? The difference between 4-bar and the slider, inverted and slider crank. If I make, just think about this mechanism. If I just make a joint here, then the number of links from 4 is gonna change to 5 because this slider is gonna be individual link because it has a joint which can connect the slider to this link. It has another joint which can connect the slider to this link. So then I'm gonna have 1, 2, 3, 4, and 5. And the number of joints also would be different. 1, 2, 3 pin, 4 between the slider and this, and 5. Is that clear? Alright. So let's back to our problem, which is inverted slider crank. Let me label the links. O to A, B, O4. This length is B. From A to this position to this location is called, this is A, this is B, this is C, and this is D. For this link, I measured the angle with the ground at point O2. I labeled that with theta 2. For this link, I draw the ground line at point B and I measure angle of theta 3 at this point. Yes.
Where exactly is point B?
Point B, just think about intersection between this link and this link. I don't want to put a dot because you might think that we have a joint there.
I just want to know if it's like the front
Yes.
side, the back side, or the middle of the side.
Yeah, exactly at the middle of the slide. And theta 4, for this link, I measure theta 4 at point 04. And this angle, gamma, which terms are constant? If you look at this mechanism, which terms are constant?
A, B, C.
A, B, C. Okay. The variables would be theta 2, theta 3, theta 4, and B also is varying when the mechanism is moving, the slider is moving along. That is theta 2, B, theta 3, and theta 4. Nouns would be constants plus 1 degree of freedom. So I assume theta 2 is given. Unknowns would be B, theta 3, and theta 4. So I defined one angle here with the gamma. Gamma is fixed or is constant or is varying while the mechanism is moving. Fixed. It's fixed because there is no rotational motion possible between link 2, 3, and 4 because we don't have any pin there. So it's fixed. So it means gamma is constant. I added right there. Now, just think, I'm gonna move these two lines right here to show you. And this is gonna be this line. I extended. This is point B. This is point 04. So this angle is theta 4. This angle also is gonna be theta 4. Two parallel lines, one is crossing. So these two angles will be equal to each other. So if I extend this angle will be theta 4. So as you see, I can write theta 4 plus this angle is gonna give me theta 3. Theta 4, which is this, plus this angle is gonna give me theta 3. So it means theta 4 and theta 3 are they are dependent with the constant value of the gamma. So they are not independent. So because I should be varied here because I have 3 unknowns, but I know that with one vector loop equation I can get 2 equations, and 2 equations can solve for 2 variables. But here I have 3 unknowns. But I know that theta 4 plus, if this is gamma, this is gonna be 180 minus gamma. So I think the book assumes this is 90, so it assumes this angle also is equal to gamma. So, but for now I'm just writing 180 minus gamma. It's gonna be equal to theta 3. Now let me form the vectors. O to A is one vector because we measured angle at this point, so it's going to be the head of this vector. The head of this vector is going to be point B. I put the tail at point A. I measure theta 4 at the head of this link. I put tail over there. Similarly for this. So I can see point A has 2 arrows ending to that. Reach to point A through 2 different paths. O to A. You just reach point A, put equality sign there, try to move to reach to point A via this path. O to O4 plus O4B plus BA. X component would be A cosine of theta 2 equals to D plus C cosine of theta 4 plus d cosine of theta 3. And here for y component, just change cosine to sine. A sine of theta 2 equals to d doesn't have any y component, or d sine of 0 is 0. C sine of theta 4 plus b sine of theta 3. Equation 1, equation 2. I just want to change this 180 minus gamma, so by defining this angle as a gamma, because the book doesn't have this, so we might have different notation. So theta 4 plus gamma equals to theta 3. It's not going to change the logic of the problem. I just change the angle with the other one. So in these two equations, b is one of our variables and theta 3 is another one, or theta 4. So what I'm going to do, I'm going to find b from this equation, from 2 a sine of theta 2 minus c sine of theta 4 dividing by sine of theta 3 equals to b. I just find b. Now substitute b in 1. A cosine of theta 2 equals to b plus c cosine of theta 4 plus b. A sine of theta 2 minus c sine of theta 4 dividing by sine of theta 3 multiplied by cosine of theta 3. To get rid of sine of theta 3, I multiply both sides by sine. Plus a sine of theta 2 cosine of theta 3 minus c sine of theta 4 cosine of theta 3. Alright, we have one equation, theta 2 is given, we know theta 2, theta 3 is unknown, theta 4 is unknown, but we can substitute theta 3 by theta 4 plus gamma. So then it's gonna change the problem to a cosine of theta 2. Wherever you see theta 3, change it to theta 4 plus gamma. Sine of theta 3. Now the only variable or the only unknown is theta 4 because gamma is given. So we know that cosine of theta 4 plus gamma is going to be cosine of theta 4, cosine of gamma minus sine of theta 4, sine of gamma. And so wherever you see sine of this, just expand that. Wherever you see cosine of theta 4 plus gamma, just expand this by using this equation. If you do that and simplify the equation, you will get this equation that I will write in this part, in this section. A sine of theta 2, so A cosine minus D times cosine of gamma plus A sine of theta 2 sine of gamma, this times sine of theta 4 plus A cosine of theta 2 minus D sine of D times sine of gamma cosine of gamma. This is gonna multiply by cosine of theta 4 minus C sine of gamma equals to 0. So this term times sine of theta 4 times cosine of theta 4 minus this equals to 0. This is the equation that we can get, and we will get the solution on Monday for this. It's very similar to the 5-bar mechanism equation, just different terms. We should use the same techniques, tangent half angle, to find for theta.